Hi, I'm Dave Ormsbee from Axim Collaborative.
I'm Braden McDonald. I'm from OpenCraft.
And I'm Kyle McCormick from Axim Collaborative. And the title of our talk is Farewell MongoDB, Migrating Content to a Relational Data Model.
Okay, hi everyone. Thanks for coming to our talk. I'm Braden McDonald here with David Ormsbee and Kyle McCormick, and we're going to be talking about getting rid of MongoDB in OpenEdX platform. I'm going to start with a bit of background on MongoDB and why we want to get rid of it. And then I'll let Dave and Kyle talk about what's coming next and what's going to replace it. For those of you who don't know, I'll just very quickly say what MongoDB is doing in OpenEdX platform. This is the architecture diagram that comes from the official OpenEdX documentation. You don't need to know most of the details here. The main important parts are, in blue, you can see the LMS and Studio, which everyone knows. They use a storage manager to store course content, which is ModuleStore, and library content, which is currently Learning Core. And in turn, they store all their data in these actual databases: MongoDB, MySQL, S3, Redis, Meilisearch, and ClickHouse, and some other ones too. So MongoDB is strictly used for courseware and files, like you upload in the Files and Uploads page of Studio. The question is often asked by people who look at this diagram and know what MongoDB is or don't know, is why do we use MongoDB? And there's a 9-word answer to that question. It seemed like a good idea at the time. If you go back to 2012, it was a time when, Obama was reelected as president, CERN was announcing the Large Hadron, the Higgs boson was detected in the Large Hadron Collider. And somewhere in Massachusetts, OpenEdX was being developed and MongoDB support was added in one of the very early versions of the platform. So part of the rationale for this is that MongoDB is designed for really big data, and we expected to have a lot of data for courses and content. MongoDB was schemaless, and with X blocks, we don't know what sort of X blocks people will make, so it seemed like having a schemaless way of storing course data could be a good fit. And there's this thing called GridFS that lets you store files in MongoDB. So maybe we don't need a separate file storage system if we can just store files in MongoDB, which we're already using. Plus, at the time, MySQL didn't support JSON, which is a nice way to represent our XBlock data. And so MongoDB, we went ahead with. But now it's a bit like this situation where you have a mini chainsaw on your plate, but you just need to cut up your food. And since we already have a fork, maybe we can just use a knife. I was scraping the barrel for an analogy here. Now I want to talk about why we want to get rid of MongoDB and the related ModuleStore system that wraps around it, which you saw in the architecture diagram. One of many reasons is the way we store courses and course content in MongoDB. We have these giant structure documents that hold every component and every unit and every subsection and every section in the course. And I wanted to show a screenshot of how big they were, but it took me more than 2 minutes just to scroll through in this video so you can get a sense of how big these documents are. The problem is every time you change anything in the course, we create a completely new copy of this document, and these build up a lot over time. This ModuleStore system that manages MongoDB for us is also super complex. So if you just want to create an X block or something using its API, it's fine. You can copy an example and use that, no problem. But if you want to understand it and modify it or fix a bug or something, I mean, look at this: populated locators, post-save version, version GUID, head of the given course branch, fork the structure, and don't update the course draft version, multi-step transactions, definition locator, local ID. There's a lot to understand here, and you can wrap your head around it if you want to spend a lot of time. And I have done that at various points in time, but it's not a fun experience. So this has been a bottleneck kind of holding back innovation on content storage in the core platform. nobody really wants to work much with this complicated code. And if we can replace it with something simpler and more flexible, then I think it will unlock a lot of innovation. And that's what Dave and Kyle are going to be talking about next. Just a couple more things. When you upload a file today in OpenNX using the Files and Uploads page in Studio, it gets broken into these little chunks, these tiny little 256 kilobyte documents that you see here, and stored in MongoDB. And that's not only an inefficient way to do things, it's also a pretty expensive way to do things. We use MongoDB Atlas at OpenCraft, and I checked the pricing for each additional 50 gigabytes of course content, and that's not an outrageous amount. It costs 20 times more to store it in MongoDB than it does on Amazon S3. So if we can just store files on Amazon S3 instead of splitting them up into little chunks and storing them in Mongo, we can save some significant money. So in summary, we don't really use the capabilities of MongoDB. We can reduce the complexity of the system if we replace it with something simpler. We can save money by storing files on file storage instead of in a database system. As you'll hear, we can get real foreign keys, and we can unlock future development by avoiding this thing that nobody wants to touch right now, and get a simpler API. So I don't know if you can see the date here, but in 2021, we have a DEPR or a proposal to replace MongoDB, and it was called overdue at the time. Well, we're finally making progress on it. That's the end of my section. I'm handing it over to, which one of you is next? To Kyle.
So that's where we're coming from. Let's talk about where we're going. Learning Core. So what exactly is Learning Core? Why will it be better? Why are we not just recreating the issues that we had before? And how does it fit into the platform as a whole? Who here is familiar with the Unix philosophy of design? Can anyone, Chidij, what is the Unix philosophy?
It's having small composable to work together instead of overloading one thing with a lot of features.
Exactly. Doing small tools that do one thing and do them well. And that's in reference to command line tools in Unix or in Unix-like operating systems. But the same thing we can apply to APIs. XBlock is not one of those APIs. XBlock tries to do a lot of things. Some of those things it does well. It is an architecture for creating custom components in your course. And it's been very successful at that. We have thousands of XBlocks that have been made. Raise your hand if you've worked on or made an XBlock before. Cool, several people in the audience. Keep your hand raised if you've worked on an XBlock that has children. Fewer hands. Was it a good experience? No, it was not. It's terrible. So XBlock does some things well. XBlock tries to do a lot of things though, and one in particular, managing the structure of a learning context, managing the structure of a course, it doesn't. And it's kind of like a multi-tool. It tries to be your one tool that does everything. And some of those things it does well, like I'm sure that bottle opener comes in very handy, and that screwdriver probably comes in handy. I cannot imagine ever using those pliers or that hammer for anything. And not only are they useless, they're also taking up weight on the tool and making it more clunky and harder to use. So in a similar way, managing the fact that XBlocks have to manage children makes the whole API more complicated and more error prone. Why am I talking about XBlocks? Because ModuleStore stores XBlocks. Expressly, it stores XBlocks. And over time, the distinction between those two APIs became muddied, where all the things XBlocks was trying to do got muddied with the additional things, publishing and versioning and content reuse, that ModuleStore was trying to do. And instead of being two distinct APIs, it became this one muddy system in edX platform, where some of that system, the custom components architecture that XBlock provides, was stable and is useful, and you can and should write plugins using it, whereas other parts of it that weren't clearly delineated were not stable and were likely to break from release to release or just not work at all. And we really weren't clear on exactly where those boundaries are. Furthermore, ModuleStore only works on MongoDB. And as Braden pointed out, we'd really like to get rid of MongoDB. So why haven't we done it? Well, because we're not going to get rid of XBlocks. XBlocks have been codependent on ModuleStore, and ModuleStore is locked into Mongo. Fortunately, over the past, actually, I think this was between like Koa and Nutmeg, several releases of separating out X modules. There was a project to separate these two APIs out. And it was successful. XBlocks can now render without ModuleStore. It's not perfect, but there is now a delineation between these two APIs, which means we are in a very fortunate state of being able to re-implement XBlocks on a new runtime. And what will that new runtime use as a storage backend? Learning Core. So to be very concrete, what Learning Core is a pip-installable Django app that provides a suite of simple, stable, and statically typed Python APIs for managing generic learning content built on relational data models. These are fairly low-level APIs, and they're broken down into 4 or 5 sub-APIs. Each of those sub-APIs is like a Unix tool. It does one thing, and it tries to do it well. These APIs, once they reach their 1.0 version, they will be stable. We'll avoid breaking changes to them, and when they do happen, we'll announce them using deprecation tickets. They're all statically typed for your convenience as developers, and they're all generic. If you look at this, there's nothing here that says XBlock, which might be surprising, since XBlock is our learning content platform, and this is also going to be our new learning content platform. So why doesn't it mention XBlock at all? You'll see that in a little bit. But what I will say is that there is a complementary suite of concrete APIs available in edX platform now that do implement a new XBlock runtime using these. So let's dive into the low-level APIs, because this is what will be available to plugin developers. Firstly, the publishing sub-API. At the core of Learning Core is the idea of a learning package, which is a thing that stores other things, those other things being entities. Each of those entities has a history of versions, where one of those versions is the draft version, the version someone is editing, and for things that have been published before, one of them is the published version. Concretely, a learning package could be something like a content library. Who here has seen the new content libraries feature? Excellent. That is implemented as a learning package. And every item in the content library is an entity. And entities can exist in unpublished, published, and draft states. What are entities, though? Well, before we talk about that, let's talk about what they can have. Contents are just static files, or static blobs of data, basically. And they can be stored in an object storage service like Amazon S3. An example might be an SVG file, an XML file. These are versionless, and they are identified by their hash, so we can cache them between entity versions. When we take an entity and associate it with contents, what we get is a component. There's nothing abstract about this. This is exactly what you think it is. A component is in Studio. When you add a component to a course, that's what we're talking about. And how it's implemented in Learning Core is the combination of a versionable entity with some contents. And these are the component types that I'm sure you recognize: text, video, and so on. As a concrete example of a component, we have an HTML block in a content library, which in Learning Core parlance is an entity in a learning package, or a component in a learning package. The operative parts of this component are the key, which you can see up in the URL bar, and the title, which, by the way, in new content libraries, keys are based on titles by default. So we have human readable URLs finally for components. And lastly, we have the contents highlighted in the middle here. We can drill into that a little more using the library sidebar. You see the same stuff here. So clockwise from the top right, we have the key of the component, the title, its version history, which was hidden from you before, and its contents. although its contents here, notice, are broken into two things. The OLX source, that's the XBlock source code, and the static asset associated with it. Remember that I mentioned that that learning core doesn't know anything about XBlock? That's true. If we dive in a level deeper into Django admin, we'll see that in the bottom right here, these contents, it doesn't say the source of this component. We just have an XML file associated with it. And together with the other pieces of metadata, the title, the key, and the versions, we have a component. And the only thing that Learning Core knows about this related to XBlock is the component type there, XBlock v1 HTML. And this essentially tells edX platform to interpret this component as an XBlock. So you might be wondering why we have this separation. If all components in the OpenEdX platform are XBlocks, why have we separated out the idea of components from the idea of XBlocks in our architecture? Well, for two reasons. Firstly, we might not want to only support XBlocks forever. We might want to support other learning standards, things like QTI, Prairie Learn, or other things. Secondly, even if we never do that, there is value in separating concerns, keeping our tools separate, so that if there's a bug or if you want to add a new feature to one of these two systems, you don't have to worry about the complexity of the other feature. Entities can be put together into containers. These are the container types I'm sure you'll recognize. Units made of components, subsections made of units, and sections made of subsections. And I want to take a moment to celebrate here. This is the first time in 15 years of OpenEdX existing where there are actual relational data models for units, subsections, and sections. Amazing, right? And so if you were, for example, writing a plugin that added the idea of like a recap of a subsection, could be a unit somewhere. If you wanted to make a data model for that, in the old world, these would have to be usage keys that just pointed to arbitrary XBlocks. And if you had a subsection recap where one of the usage keys pointed to, I don't know, a problem and the other pointed to the course itself, you'd have like a corrupt data model, and you'd have to have validation or fallback behavior to handle that. Whereas in the new world, you just make them foreign keys to subsection and unit, and you can use all the advantages of the Django ORM there. But we don't want containers to only ever be subsections, sections, and units. We want to be able to support different structures of courses, smaller courses, pathways, things that we haven't even dreamed of yet. And for this reason, all those container types I mentioned are implemented entirely as generic containers, where a container is something that has versions and has a key. And the only thing that marks it, in this case, the only thing that marks this container as a subsection is that there's a subsection model pointing at it. So if you wanted to develop your own OpenEdX plugin that added a new type of container, you would make that a model with a 1-to-1 foreign key to the container, and then implement the logic you needed associated with it, and it would work with Learning Core. The folks on the stage are doing exactly that soon, most likely. We need to support dynamic content in Learning Core eventually, soon actually. And one way we're thinking of doing that is the idea of a selector, which would be a container that shows a different subset of its children to different users. And two concrete use cases of that are a problem bank and a content experiment, where a problem bank would show a random subset of its children to users, and a content experiment would show some subset of its children to different users depending on attributes associated with them. These exist as XBlocks now, and we're going to implement them as containers in the future. And lastly, there's collections, which are a feature in content libraries. So putting it all together, that's the authoring API. The authoring API is the first API and the only API so far that we've added to Learning Core. But we'd like to bring the same philosophy of simple, generic, statically typed relational APIs to other parts of the platform, scheduling, grading, user differentiation, and so on, such that once this is all ready to be consumed, your plugins, instead of just using XBlock, the XBlock API, and consuming events and hooking into OpenEdX filters, will also be able to hook into the data models that power the learning experience without MongoDB. So where we started, all content was stored in ModuleStore. Where we are now, courses are stored in ModuleStore, content libraries are stored in Learning Core. And where we're going is everything will be stored in Learning Core with the ability to write plugins against it. This will take some time to get to, unfortunately. We have to basically rewrite the whole course authoring experience. However, it's closer than you might think, and I'd like to demonstrate that. OK. Good. Here's the demo course. You all recognize it. Mongo is running. If I stop Mongo, the demo course stops working, unsurprisingly. However, we have a tool that is getting close to being production ready that migrates content from courses into libraries. And we run this on the demo course, which gives us now the option to switch that course over to use Learning Core. So now if I reload the demo course with Mongo still stopped, look at that. No MongoDB. Yeah, and it can even, navigation works too. And a funny artifact of this is that because all this is stored in Learning Core, we've done a little hack just for fun that makes it so we can edit this content using the content libraries interface. So here we are in content libraries, editing this drop-down problem from the demo course. Hello, OpenEdX 2025. Bigger. Yeah. Oh, I tested this before, but it should be bigger now. Voila. And with that, I will hand it back to Dave to talk about how exactly we're going to undertake this migration.
All right. So how did this demo actually work? What is going on here? And what does that mean for the overall migration process that we're proposing? So a couple of things in the right up front. First, this is very much a work in progress. So this is a prototype, early stages. Also, I'm going to be talking about this largely from the technical point of view. There's a whole separate sort of product and UX conversation about what a migration might look like. This is just about those are important conversations, but they're just beyond the scope of this talk at the moment. Okay, so when we're thinking about the transition from storing things in ModuleStore to Learning Core, it's useful to think about where does Learning Core fit into this? It's tempting to think, okay, we have an XBlock runtime, and that XBlock runtime, stores its XBlocks in ModuleStore. That goes to MongoDB. So we can just implement a parallel path. We can point that XBlock runtime to Learning Core, and it'll store things in MySQL, and easy. Except this is a lie, right? This is, or at least this is a gross oversimplification, and it's a much more complicated picture than that. And one of the first reasons why is because ModuleStore is everywhere. It's most edX platform applications either call ModuleStore or call something that calls ModuleStore as part of its key functionality. It is called over 1,000 times across hundreds of modules in edX platform alone, and that's not counting plugins and wherever and other repos that get hooked into edX platform. So the takeaway from that is that we have to preserve the ModuleStore interface. It's not going to be practical for us to stop the world and point everything that pointed to ModuleStore, point it to a new place. Now, we have a lot of different use cases, a lot of different uses of ModuleStore. Sometimes we want just configuration data. Like these separate apps want just a couple of fields that are on the course configuration. Sometimes you want a few fields across many blocks. Like if you want to generate an outline, you want titles and a few other parent-child relationships, but you can ignore most of the other data. Sometimes you want basically all the information about a few blocks, like when you're rendering X blocks. And sometimes you want all the information of all the things, like if you're implementing search or the course blocks API. But on the bright side, this is almost always for reads, not writes. Very few things actually write to ModuleStore as compared to the number of things that read from it. So I guess a modification of the previous takeaway is that we need to preserve the ModuleStore read interface. And maybe we can get away with changing things on writes. So the other complication is that ModuleStore, the interface and logic are complex. Braden already covered some of this. Some other fun things for those of you who are familiar with CCX, that happens as a wrapping layer around ModuleStore. Field inheritance, as well as default values, that gets calculated in ModuleStore, and as well as the special exceptions to that, edge cases get calculated in ModuleStore. And then you have fun comments like this, which just is inspiring, I know, when you have, however, this will work most of the time. Like that really instills the confidence. So the takeaway from this is that making a compatible reimplementation is tricky, right? If we try to take all the public and pseudo-public interface of ModuleStore and rewrite it all to use Learning Core on the back end, we're going to miss some edge cases. There are going to be bugs. It's going to be this long tail of painful things that we'll have to track down. On the other hand, ModuleStore's data format is actually really simple. It's not pretty, it's not performant, but it's really simple. Because ModuleStore has the structure doc, the giant structure doc, that stores all parent-child relationships, sections to subsections to units, etc. It also stores XBlock setting scoped fields. So for those of you who don't know what those are, those might be things like the title, the due date. The structure document has pointers to definition documents. Now, these aren't actually relational pointers or anything. They're just, IDs, but that's the world we're in right now. But those definition documents store XBlock content scope fields. This would be like the text of a problem. And the serialization for those fields are fairly simple because that's defined in the XBlock core API itself. And yeah, that's pretty much it. So the takeaway from this is that a lower level approach is feasible. And you folks might be realizing at this point where I'm going with this. The thing what we are proposing right now, ModuleStore accesses these documents via calling getStructure and getDefinition, and those hit MongoDB. What we're proposing is, and how this demo worked, is we're going to have Learning Core generate structure documents. Now, the Learning Core's source of truth is still going to be all the models that Kyle was talking about. But when you hit publish, it generates the structure documents and it has a shim layer. And so later on, ModuleStore is going to call this shim layer. It's going to get structure and get definition from the ModuleStore storage shim that lives on top of Learning Core. And the nice thing about this is that we don't actually have to touch most of ModuleStore code. The weird edge case handling, deciding this inherits this except on Wednesday afternoons, like all of those rules stay in ModuleStore, and we don't have to touch it and worry about the compatibility headaches that would come from touching it. So the advantage to this is that it lets us get off of MongoDB much more quickly, right? So we'll be living in a world where once we do this migration, Learning Core will be pushing data into ModuleStore in a format that ModuleStore can understand. as these structured documents. And then everything else, all the other apps, and there are like 100 other apps out after this, they are still reading from ModuleStore in the same way that they've always been reading from ModuleStore. And the next migration that we would deal with over time is that once this has been established, once we're in this state, things work, but you don't get any of the advantages of learning core on the LMS side. You don't get faster queries, you don't get better data model, you don't get static type, you don't get any of those benefits. But over time, these apps will be able to bypass the ModuleStore layer and talk to learning core directly and to get the benefits of these APIs. And the idea is that over time, the footprint of ModuleStore gets smaller and smaller. And this is a years-long process, but this is where we want to go. And of course, incentives to switch your app, we're not going to be just, eat your breakfast type of, you must do this because it's good for you switching. There are a lot of incentives. If you are writing a plugin, the CI and testing story is much easier. All the data model goodness that Kyle went over. You also get better performance because if you have a configuration value you want to access on one thing, you can actually just access that one thing, and you don't have to access the 2 megabyte structure file in order and calculate all the inheritance to get that one thing. But backwards compatibility. Okay, so I just described the whole process by which we would try to, let ModuleStore be ModuleStore and only change things at the lower level. And that was for compatibility reasons, but there are certain things that we might need to seriously look at. So first of all, if it works in Studio, it'll still be supported in the Learning Core world. If something is OLX only, there might be breaking changes, but we will deprecate. It will go through the whole normal deprecation process, and you will have a time to advocate for and discuss it. And so one of the examples of why we would do this. So there's something, OLX lets you specify information at pretty much any level of the hierarchy. And, in one way this can be good because it doesn't introduce a lot of flexibility. On the other hand, so take due dates. A typical course has maybe 1 or 2 dozen due dates because they have, those due dates are on the assignments. In the Studio interface, you have to set those due dates on the subsection. However, they are actually stored, and the OLX will allow you to store at any level of the hierarchy, including if you want every problem in your course to be due 5 minutes apart from each other. Technically, the data model lets you do that. But the consequence of that is that it explodes the amount of data we have to store, and it makes designing downstream systems more difficult, right? If you want to build a performance scheduling system and you have to deal with 2 orders of magnitude more data because we technically allow for this functionality that is never exposed in the UI, and very few people that I'm aware of use, then it's worth the conversation of whether that feature is worth keeping or not. So tentative timeline. Okay, this is where I wave my hands a lot, and this is not a promise. This is just our best guess at the moment. Okay, this is not a guess. So Teak has been released. It has the beta content libraries with support for units. This is built on Learning Core. OMO at the end of the year. Content libraries will support subsections and sections. Those of you who might be looking at development builds, you can already see a lot of this has been built. We also plan to add front-end plugin slots support for content libraries. But next year, so you will not be able to run your courses on Learning Core in this year, unless you check out our special branch. But like, it's a prototype hacky branch. Do not use it for production. And you like, I just want to say, do not use it for production, please. But next year it might be feasible to have OLX courses without MongoDB, in the sense that you should be able to. We have the backend mechanism to take a course content and push it in. We don't have scheduled any work to rebuild all the course UI side, editing UI side, to use Learning Core. Because keep in mind, like we're saying here, that the shim layer is going to exist for reads, but the write layer would have to be redone. There are other things that are being worked on that are smaller than courses, and that are sort of being built from the library's point of view. So, again, these are all very tentative at the moment, but mini courses, diagnostics, pathways, backend plugins for those. Like this is, so yeah, please, if you are curious about the direction of this, Jenna and Sam, who are working on the content libraries, are definitely people to talk to. But I just want to put this here to show that, porting those courses over is not an immediate priority, like from the UX, like we haven't planned the UX side of this. And then, yeah, so this is real hand waving. Whenever we get 2 years plus out, it's definitely hand waving. So my hope is that in the 2027 timeline is when we can actually have fully functioning non-MongoDB courses. All right, just want to say a special thank you. So one of the things that's been fun about Learning Core and content libraries in general is that we've had folks from a whole bunch of people across the community working on it. So, the three of us have worked on it. A bunch of other folks at OpenCraft, Edgenex, Raccoon Gang, and recently WGU has joined our development team. So it's been lots of fun working with everyone. And is Piotr here? Piotr wrote some code so Piotr from OpenCraft also wrote some code that specifically helped us in our demo, for which we are very grateful. Just like, hey, Piotr, you have some time with the core contributor hours? Well, why don't just help us for a week? But yeah, he was doing great. And that's it. So any questions?
Quick question with what you showed. Does that mean that in this intermediate time that we will have Learning Core and ModuleStore saving the same information, so duplicating information?
No, not at the moment. So right now, Learning Core is only used for content libraries. The moment you use content from those libraries in the course, is being copied over to ModuleStore.
So is the verbiage changing from courses to content libraries, or is it now content libraries contain courses which then contain?
Yeah, so I think that is all very TBD. So the top level course editing interface is not going to go away. But right now, what is being built, even for OMO, is going to be having full support for sections and subsections inside of libraries. Whether it's worth putting one more level of aggregation and having multiple courses in libraries, like the data model can support it. It's much more of a product UX question about whether that is what we want or not.
Yeah, for the demo, we put a course in a library. Whether we actually want to do that as a product,
we put a course in a library because it was the easiest way to get like stuff done, with what we've already built.
Yeah, my question was around that. The demo you show about having this course in Learning Core, there is a way I can test it, some code or something we can use
Yeah,
to
we'll
play with that.
We'll send you our branch.
Yeah. okay,
Actually,
perfect.
we'll put the branch in content libraries Slack channel.
Okay.
Yeah, I'll post a link there.
Okay, perfect. Thank you.
Will any of the individual pieces of data be missing from the tarball in the future from individual pieces of content? So currently you can get the due date. We don't use it per se, except to identify it if something goes wrong. But, I can get the due date if somebody in the historical past has done something dumb and then fix it. But
So we do save all the versions. You do have a full version history, and that so you should be able to export it and look at previous versions as well. Actually, one of the big features that is being sort of worked out right now is what on the product side is actually fleshing out what those history views would look like.
Okay, yeah, no, because I know sometimes people have done dumb things in the past where they put a content experiment in there and now they want to strip it out. And you have to go and kind of remove everything.
Can I say a couple things? Yeah. So a couple things. First of all, the tarball format is not going to change for the foreseeable future, and even if it does eventually change, we would make sure that there's a backwards compatible option. I'm not even saying we're going to change it, but we'll always make sure the tarball and the OLX format is very important to the success of OpenEdX, and we have years of courses in that format. So we're going to make sure we maintain compatibility with that as the export format. Yeah. For libraries, that's not necessarily the case, and we might have a different format for libraries because there's not really a established format there yet.
So I had a question about the shim. You mentioned the shim data being generated. Where does that live somewhere? How is that working?
Okay, so there are two sort of layers. The definition documents are basically XBlock field data that we store anyways. So one of the areas that we didn't go too far into is that, with the idea of having extensible data models like we have, you can make one-to-one models for specialized sort of additional data that you want to put. So the Learning Core, the XBlock runtime creates a one-to-one model that is XBlock field data. So the XML, the OLX is stored, that file. But when it's actually being rendered, it's being rendered off of like a set of field data. And so the definition, get definition actually basically accesses that field data and, wraps it with a few trivial things that that ModuleStore expects and then passes it back. Structured document actually writes out a structured document as a blob in a in the blob field in a table in MySQL in Django Orm. Unlike split ModuleStore, we only are keeping two blobs. There's going to be a draft and there's going to be a publish. There's not going to be the history because we store history in Learning Core and we store it much more efficiently. So.
I think Kyle mentioned this briefly, but the Django admin is now so much more useful for browsing through the content that's in your course or your library and seeing what's in there. If you've ever had to do that with Mongo or with exporting a course tarball and then editing it and then importing it and making sure you didn't have any references, it'll be much easier with the Django admin to figure out what's going on with something.
Oh, sorry.
Go to click on the component key.
Yeah, so click on the components. It links you to the publishable entity, the learning package. It shows you all the versions that have been created. Go into any version and you get the OLX here, but you would also be able to get, if it had static assets associated with it, you would also see those here. So yeah, it's just, It's just a lot more useful.
Interface-wise, would you be able to?
What's that?
Sandra knows. Just so you don't scream at me. Interface-wise, will you be able to go back in time to recover some history or some previous editing? Because now you can only go once, so to the previous version?
Yeah, so that's very much the intention. I haven't actually seen those screens. I don't know if you two have. Because that is one of the things that Jenna and Sam were talking about, right? The being able to have a history of you.
We have the data, but no UI.
Yeah.
Yeah. In theory, we could make that soon in Django admin.
Okay.
Yeah, but in the longer term, there
Yeah.
most likely will be a content library.
So that again. Oh, there you go.
Yeah,
So,
get me on record.
so we have this notion of a draft change log, and every particular thing in this change log. So you can see this is one change. It was done by me at this time. There are 5 different things that were changed at the same time because it was a whole unit that was being published or that was being modified. And it shows the old versions and new version. This is also, this is a convention that might look a little confusing. So when a particular component changes, it goes from, this one from version 9 to version 10. These all stayed at the same version, but they're included in the draft changelog because they're the parents. So you can see that, this thing actually changed. These other parents, ancestor nodes were affected by this change, even if their particular content, even if the metadata associated with those didn't specifically change. But yeah, we have this. We have the equivalent of this for publishing. There's a lot of detail in terms of who changed what at a very granular level.
So as one of the people who raised their hand about dealing with X-blocks with children, how would that work, or would that not work anymore?
It won't work. No, excellent. So I think we're trying to push to get children out of X-blocks entirely and to have dedicated things for it. So the X-block API eventually we think is still a valuable plugin API, but the thing that 99% people use it for is creating custom components, and that's what we would want to focus on. And other parts of the API we would want to gradually remove.
I think what we absolutely have to remove are children above the unit level. For children of components, I think that's a discussion we could have whether we maintain backwards compatibility. But either way, there will be a Depper ticket for it and a timeline for removing that.
And in the precursor to Learning Core, which we called ModuleStore, when we were integrating that with the XBlock runtime, managing XBlock children was such a huge pain point in the implementation. It makes me really want to try to avoid that if we can in this one. So that will be a discussion that we're having.
So it wasn't super popular when it happened, but we had this tool, Tubular, to prune old versions because the Mongo database was growing so large. Are you foreseeing that this is something that we also have to do here? There will be different tooling, or is it because of the data model not something that we'll probably be facing?
So one thing is, first of all, we're not storing files and uploads in Mongo anymore, so that will already reduce the amount of space. It's very cheap to store stuff on S3, so you can have lots of that data. But we are storing a complete version history of all the other data, as you can see. So.
But on the other hand, the where this is stored. So what I showed here, and why? Always wants to show a dictionary. All right. We do store data for all these changes, but when you change a component in Learning Core, you write a new version of that component, and you make these annotations in the draft log that say, okay, and these were the affected containers that 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 this change affected. We don't write a 2-3 megabyte structured document that has all the contents of the course, which is what a ModuleStore had, and you don't like keep that version history forever. So so we still have to measure it. Like, I think but I'm hopeful, I'm optimistic that it grows much smaller and it's just not as much of an issue as it was.
Yeah. The images in XBlock source are also not duplicated if they don't change. When I was talking about the contents and how those are versionless files identified by hash stored in S3, yeah, we're not making copies of those every time you make a change to make one of these changes.
We are over time, but I think people are interested in questions, so I'm going to keep going until you guys stop.
Hi. So you talk about storing the content in S3. Is that the only option, or are there going to be options for the storage?
So actually, this is funny. When we did BlockStore, we tried to do everything in S3, and one of the things that hits very badly, I'm sorry, to say, what we actually mean is Django storages is the backend. So if you want to store it to a local file system, MinIO or whatever else, that part is entirely pluggable.
Okay.
But there's also another layer where some things are stored, some blobs of text are stored in the database itself, in MySQL. And some of them are stored in an object file store. And the difference there is pretty much when you want to optimize for cost versus latency. And so the OLX for an individual problem, that and the field data, that is stored in the database table because we can have very consistent like sub-millisecond latencies. Things that are much bigger, more expensive, like the like images, those and PDFs, those we would store in the object store, where a little extra latency doesn't hurt us, but we just want to optimize for large, cheap storage.
Okay. Yeah, the reason I was asking is because you have a lot of S3 compatible services, which are compatible, and then you have surprises after the fact with stuff that does not work.
Yeah.
So that was the reason.
Yeah. No, I mean, we use Django. The Django storages is we sort of leave that compatibility to the Django storages library, and we don't use it in any sort of exotic ways. We use it in very straightforward storage ways. So we've been okay so far. We've definitely run it both locally on MinIO and on S3, and it's been okay so far.
Okay, thanks.
And we use DigitalOcean Spaces for a lot of stuff too. It works perfectly fine with all this learning course stuff.
If you're worried, try it with all the libraries that are available and let us know if it's not working with the storage that you care about.
Thanks a lot for coming to our talk, everyone.